So hopefully you have taken this old trigonometry exam, taken it like it was a test, didn't use any resources, and uploaded that to Canvas. Now we're going to go over that exam. I'm going to show you the solutions, and I want you to grade what you had taken like a practice test, grade it, and turn it in onto Canvas once it's graded. So let's go over the solutions to this test that you took. So you want to find these following, the exact values of each trigonometric function. On this test, no calculators are allowed. We're looking at sine of 11 pi over 6. So while you're doing this, show as much work as possible. So if you're given a trigonometric function at an angle, maybe graph that angle, tell me what the reference angle is, etc. So if I'm looking at 11 pi 6, I notice that I just need 1 pi 6 to get up to 2 pi. 12 pi 6 is 2 pi. And so to me, that is going to be in the fourth quadrant. And so my reference angle in here is pi 6. I would think to myself, sine in the fourth quadrant, is that positive or negative? Well, sine, which is the y value on the unit circle, is negative in the fourth quadrant. So sine of 11 pi 6, this is the same thing as negative of sine of pi 6. So we have negative, well, sine of pi 6 is 30 degrees, is the 1/2. So our answer is negative 1/2 here. So cosine of negative 5 pi 6. Negative 5 pi 6, that's telling me if I were to draw that angle, it's a negative angle, so I'm going clockwise 5 pi 6. I notice I need another pi 6 to get up to negative pi, or negative pi 6. And so my angle would fall in quadrant 3. My reference angle in here is pi 6. I would think to myself, cosine, is cosine positive or negative in this third quadrant? Well, cosine is negative. And so this is equal to the negative of cosine of pi 6. So this is equal to the negative. Well, cosine of pi 6, or cosine of 30 degrees, is the root 3 over 2. So our answer is negative root 3 over 2. Secant of 210 degrees. 210 degrees. So let's graph that angle. Well, I know a semicircle, that's 180 degrees plus 30 more degrees would get me 210 degrees. So my reference angle in here is 30 degrees. I'm going to rewrite this in terms of cosine. Secant is the same thing as 1 over cosine of 210 degrees. Well, I'm going to use my reference angle, cosine again, and the third quadrant is negative. So I have negative cosine of 30 degrees. Well, cosine of 30 degrees is root 3 over 2. So I have 1 over negative root 3 over 2. I'm going to need to rationalize my denominator once I flip it. So this is negative 2 over root 3. Multiplied by root 3 over root 3. So this gives me the negative 2 root 3 all over 3. Tangent of 3 pi fourths. I know that if I graph my angle of 3 pi fourths, I would be in the second quadrant. My reference angle is pi fourths. I know that tangent in the second quadrant is negative, so this is the same thing as negative of whatever tangent of pi fourths is. I know tangent of pi fourths, that's the same thing as sine of pi fourths over cosine of pi fourths. Those both give me back root 2 over 2. And so root 2 over 2 divided by root 2 over 2 is 1. And so this gives me back negative 1. E, cosine inverse of negative root 3 over 2. Okay, so I'm dealing with a cosine inverse. So I need to think about it. Which values am I between? For cosine, I'm between 0 and pi. I know cosine is negative in that second quadrant. I would kind of first think about it. My reference angle. Well, let's think about it. What angle in the first quadrant gives me back √3/2 for cosine? Well, that's 30 degrees or pi 6. So I know my reference angle is pi 6, but I'm contained in quadrant 2. So if I look at pi 6 or 30 degrees, my reference angle, then that would be pi minus pi 6, or 6 pi 6 minus 1 pi 6 is 5 pi 6. So my answer here is 5 pi 6. Cosine of 7 pi halves. Well, I notice that's more than 2 pi. So I would look at what is 7 pi halves. Let's rewrite that. Well, 2 goes into 7 3 times. So this is the same thing as 3 pi plus a pi halves. Well, 3 pi, that gives me 1 full revolution plus a semicircle. That's 3 pi plus a pi halves. So this would get me down to the negative y-axis. Cosine, which is our x value on the unit circle, that's the same thing as, this would have been the same thing as cosine of 3 pi halves, which is equal to 0. Cosine squared of 45 degrees plus sine squared of 45 degrees. So that's one of our trigonometric identities. It's our Pythagorean trigonometric identity, cosine squared theta plus sine squared theta. As long as those angles are the same, that is equal to 1. H says sine inverse of -1/2. So it's a sine inverse. Sine inverse, that's bound between negative pi halves and pi halves. I notice my sine inverse is negative, so that means I'm in the fourth quadrant between negative pi halves and 0. I would first think about it to myself, sine of what gives me back positive 1/2. So my reference angle is 30 degrees or pi 6. But I want it to be negative, so this would equal negative pi 6. Okay, so part number 2, find the exact value of the composition function. So I have cosine of sine inverse of √3/2. So let's evaluate sine inverse of √3/2. So again, sine inverse, I'm between negative pi halves and pi halves. Sine inverse of √3/2, it's positive, so I know I'm in the first quadrant. I'm thinking to myself, sine of what angle is √3/2, which is 60 degrees or pi thirds. And so sine inverse of √3/2 is pi thirds. Now I can evaluate cosine of pi thirds, which would give me back 1/2. Part B, I have sine inverse of cosine of 2 pi thirds. So I want to evaluate cosine of 2 pi thirds. If I graph 2 pi thirds, that is going to be in the second quadrant. My reference angle in here is pi thirds. I know that that's going to give me a negative, because cosine's negative in that second quadrant. That's the same thing as negative of cosine of pi thirds. So this is sine inverse of negative of cosine pi thirds. That would be negative 1/2. I would ignore the negative for a second. I would think, what value of sine gives me back 1/2, which is 30 degrees or pi 6. but sine inverse of a -1/2. So I'm between negative pi halves and pi halves. So I'm in the fourth quadrant. And so this would be equal to negative pi 6. The following here, we have cosine inverse of cosine of 5 pi fourths. An inverse and its original function normally cancel each other out. Unfortunately, 5 pi fourths is not part of cosine inverse. Let's look at cosine of 5 pi fourths. So 5 pi fourths, that's going to get me in the third quadrant with a reference angle of pi fourths. I know cosine is negative in that third quadrant. So this is the same thing as cosine inverse of negative cosine of pi fourths. I know cosine of pi fourths is √2/2. And so that's going to give me negative √2/2. So I have cosine inverse of negative √2/2. If I'm talking about cosine inverse falls between 0 and pi. Cosine's negative in that second quadrant. And so I know my reference angle is pi fourths in that second quadrant. So pi minus pi fourths is going to equal 3 pi fourths. Cosine of tangent inverse of 5 fourths. Unfortunately, I don't know what angle of tangent would give me 5 fourths. So this is where we want to create our triangle. So let us choose A to equal tangent inverse of 5 fourths. So if I took the tangent of both sides, I know tangent A is equal to 5 fourths. So for my triangle, choose an angle A. That's not the right angle. And I know that tangent is opposite. So opposite of A would be here over adjacent. So adjacent would be 4, would be here. I need to figure out what my hypotenuse is. I know my hypotenuse, let's just call it C. C squared equals 4 squared plus 5 squared. C squared equals 16 plus 25. C squared equals 41. So C is equal to √41. So I can rewrite this. This is the same thing as cosine. Well, tangent inverse of 5 fourths we called A. So this is the same thing as cosine of A. So now looking at our triangle, I know cosine is adjacent. So adjacent of A is 4 over the hypotenuse, which is √41. We tend to not like radicals in the denominator. So rationalizing the denominator by multiplying by √41 over √41, we get 4 square root of 41 all over 41. Number three says if cosecant theta is 5 fourths, tangent theta is less than 0, find sine theta. Okay, cosecant theta is 5 fourths. Cosecant is the same thing as 1 over sine theta equals 5 fourths. And this tangent theta is less than 0. This tells me, or should tells me, which quadrant I'm in. If tangent theta is less than 0, but cosecant, which is 1 over sine, is positive, this tells me that theta is contained in quadrant 3. So technically, couldn't I just solve right here for sine theta? I could multiply both sides by sine theta, and I would get 1 is equal to 5 fourths sine theta. I could multiply both sides by 4. So I would get 4 equals 5 sine theta. I can divide both sides by 5. So I get sine theta is equal to 4/5. Number 4, fill in the missing parts of the table. Each row is independent of the other rows. So we're given the degree, which is 7 pi 6, and we want to, or we're given the radians, we want to find the degrees. So 7 pi 6, that's going to get me into the third quadrant with a reference angle of pi 6. So I can just evaluate the following. So I know sine's going to be negative in the third quadrant. Sine of pi 6 is 1/2. Cosine is negative in the third quadrant. Sine of pi 6 is √3/2. Tangent is positive. Tangent of pi 6, or 30 degrees, that has the 3 in there, that's the √3/3. Cosecant of theta, that's 1/sine theta. So 1/-1/2 is -2. Secant theta, that's 1/cosine theta. So that's 1/-√3/2. Flip it. So that's -2/√3. Rationalize the denominator, we get -2√3 all over 3. Cotangent theta, that's cosine over sine, and that's going to give us √3. The negative of the degrees, well, let's first think about the negative of the radians since we have the radians in here. So what angle would we need to have in order to go this way? So this is like pi minus pi 6. 6 pi 6 minus pi 6 is 5 pi 6. But it's going to be -5 pi 6. It's wrong spot. Degrees, let's think about degrees. So I know I can convert from radians to degrees by multiplying by pi over 180. Oops, no, 180 over pi. Pi's cancel. 6 goes into 180 30 times. 30 times 7 is 210 degrees. So this is 210 degrees. But I want 180 minus 30, so that's negative 150 degrees would get us to the same spot. Okay, so missing pieces. I have for the second row that sine theta is √2/2. Cosine theta is -√2/2. One's positive, one's negative. Sine is positive in quadrant 2, where cosine is negative in quadrant 2. So I know that theta is in quadrant 2 with a reference angle of pi force. So pi minus pi force, which is 4 pi force minus pi force is 3 pi force. Or 180 degrees minus 45 degrees would be 135 degrees. Tangent of 135 degrees, or 3 pi force. Tangent's negative in quadrant 2, so this would be -1. Cosecant theta, so that's 1/sine theta. That's going to be to the flip it. 2/√2, rationalizing the denominator, we're going to get 2√2/2, so this is just going to be √2. For 1/secant, which is for secant theta, that's 1/cosine theta, so that's going to be -√2. Cotangent theta, cotangent of 3 pi force is going to be -1. So how many degrees? So how many degrees to get to 135 degrees? Normally this way. So that means it's a negative. So starting this way, this is 180 plus 45. So this would be -220 25 degrees. And then we want this again is pi force here is our reference angle. So I'm going to have, but I want to go negative. So I'm going to have a pi plus a pi force is a 5 pi force, a negative 5 pi force. So row 3, if we have negative 150 degrees, that's going to get me into the third quadrant with a reference angle of 30 degrees. Or pi 6. So I have a pi minus a pi 6. This is going to be negative 5 pi 6. So 30 degrees. Okay, so for degrees, that would be 180 plus 30. So that can be 210 degrees for the positive angle. 30 degrees. So pi 6 plus pi is 7 pi 6. Sine is negative in quadrant 3. Sine of 30 degrees is 1/2. So that's negative 1/2. Cosine's negative. And that is also, it's going to be negative root 3 over 2. Tangent of 30 degrees. Tangent in quadrant 3 is positive. So that's going to be root 3 over 3. Cosecant. It's 1 over sine. So that would be negative 2. Secant is 1 over cosine. So that's the negative 2 root 3 over 3. Cotangent of 30 degrees is the root 3. It's positive, so positive root 3. Okay, so thinking about when is cosine theta -1? Well, cosine theta is -1 when theta is pi. So that's 180 degrees. So sine of pi is 0. Tangent of pi is sine over cosine. So 0 over -1 is 0. Cosecant is 1 over sine, but sine is 0. 1 over 0 is it's undefined. Secant is 1 over cosine. Cosine was -1. 1 over -1 is -1. Cotangent is sine over cosine. Sine is 0 over -1 is 0. The degrees negative would be negative 180 degrees. And negative pi would get us to the same spot. Okay, so given information about the angle or the trigonometric function, we were able to find what the value of all of our trig functions were, what it was in terms of degrees, positive and negative and positive radians. So for the next example, we want to graph at least 2 periods of the following trigonometric functions and answer the following questions. So we're given that f of x is equal to 2 sine of x plus pi force plus 2. So I want to see where I'm starting. I know it's my argument that's going to shift me left or right. Also, it's going to affect my period possibly, make either faster or slower. So what I tend to like to do is think about 1 period for my trigonometric function. In this case is sine. 1 period is normally between 0 and 2 pi. So I like to sandwich my argument in between those values 0 and 2 pi, and then isolate my x. So if I subtract pi force on both sides, I get negative pi force is less than x is less than pi force plus 2 pi. So that's 8 pi force plus pi force. 8 pi force is 9 pi force. Okay, so I know the starting value of 1 period is negative pi force. The end value from 1 period is 9 pi force. To get the halfway mark, I could sum those together. And divide by 2 or multiply by 1/2. So I have 1/2 times 8 pi fourths. So that gives me 4 pi fourths, which is just pi. So halfway mark would be pi. To find my quarter mark, I would have negative pi fourths plus pi. Multiply by 4/4, all times 1/2. So I have 4 pi fourths minus 1 pi fourths is 3 pi fourths times 1/2, which is 3 pi eighths. To find my 3/4 point, I would sum my halfway mark, pi, plus 9 pi fourths, common denominator, times 1/2. So that's 13 pi fourths plus, or times, 13 pi fourths times 1/2 is 13 pi eighths. Amplitude. Amplitude only occurs for sine and cosine. This is a sine function. The amplitude is that coefficient in front of sine. So our amplitude in this case is that 2. The period is the length of one cycle. So if I'm going from negative pi fourths to 9 pi fourths, that's going to give us 10 pi fourths. Period is 10 pi fourths. Let's reduce that, which is the same thing as 5 pi halves. Phase shift, because I've done this with my inequalities, I can see that I'm starting at negative pi fourths, or pi fourths to the left. My domain, I don't have any trouble spots for sine or cosine, so it's going to be negative infinity to infinity. My range, though, normally I'm in between -1 and 1, but that 2 right here has stretched it between -2 and 2. The problem is, or maybe it's not a problem, but I'm shifting everything up 2 units. So if I'm shifting my lowest value of y -2 up 2 units, my lowest value of y is going to be 0. And if my max value without that vertical shift was 2, and then I shifted up 2 units, my max value is 4. So my range is between 0 and 4. So now with that information, we can graph one cycle or 2 cycles. Just because I'm running out of time and need to leave, I'm just going to graph one cycle really quickly. And so negative pi fourths was 1, 3 pi eighths was my quarter part mark. Then we had pi, 13 pi eighths, and ending value of 9 pi fourths. My midway line was 2. So we'll treat that like it was the x-axis. I'm dealing with sine. Sine starts at the max. So my max value is 4. So I'm going to start here at negative pi fourths 4. My quarter point, I'm going to hit the midway line. At pi, I'm going to hit my minimum, 3 pi eighths, back up to the midway line, 9 pi fourths. So I get this trigonometric function graph that looks like this. Okay, so I think I'm going to need to make this into 2 separate videos. I'm running out of time and I have a meeting that starts right now. So I will finish I'll recreate another video finishing the rest of this exam. Stop the recording.